Hi everyone. Today we're going to be talking about the Unit 2 part of the midterm review. So for this portion, we're going to be focusing on parent functions, which is all of the functions that we spoke about this year. This year so far we've spoken about so many functions, or at least the introduction to all of them. We spoke about linear functions, quadratics, exponentials, absolute value, square roots. We spoke about a lot of different functions, okay? But we're going to be talking about or focusing mainly on the transformation of parent functions. How do they move? How do they change? Do they get stretched, compressed, move up, move down, all that kind of stuff. So let's get right into this Unit 2 portion of the midterm review. So here we want to describe what are the effects of these letters. Now, in general, we have, I'll write it here sideways so you can see it. The general form of these functions are really f of x equals a x minus h squared plus k, where a, h, and k are the variables that we want to study, that we want to discuss and talk about. Okay, let's see. Let me move this a little bit so you guys can see it. This is the general function that we want to be able to talk about. F of x equals a, h, and k. I'll move it to the side so you guys can still see it. Okay, this is our goal. We want to be able to talk about this function right here, a, h, and k. What is it? What happens to the function as we move it around? What does the a do to it? What does the h? What does the k do to the function? Okay, we can also even see it as f of x equals a x minus c plus d. Right? We might be able to also see these variables. If you look at them right below, it's the exact same. Well, let me move this out. Let me move this back again because the one that I posted before has a square, and that's not true. I just want to focus on the general scenario, not just quadratics, but on all scenarios. Okay, so this one, I want to make sure that it can be any function, not just a quadratic. We spoke a lot about quadratics. So we have this notation that we're dealing with, any function where that has a, h, and k. Trying to move it here, snapping it, sorry. And then, like as I said earlier, we also have f of x equals a x minus c plus d. Doesn't really matter what letters you use. Notice how it's still the same thing. We're worried about what's in front of the parentheses for the a, what's inside the parentheses for the c, and what's outside the parentheses with the plus d. So it could be AHK, ACD, it could be triangle, square, diamond. It doesn't really matter. It's just really what we want to focus on is what is happening inside the parentheses, what is happening in front of it, and what is happening behind it. If you know the location of what function we're dealing with and what it's doing as behavior, we should be able to continue and solve the rest of the problems. So let's talk about number 6. 6 is dealing with inside the parentheses. When it's inside the parentheses, it's always going to move the function left and right. Now, inside the parentheses, it's always going to be the opposite behavior. So if it says plus a number, that's how many numbers you're going to move it to the left. So this function, we can say shifts h units to the left. And I'm just writing it here so that I can move it and write it nicely here for you guys. So when it's plus, it moves to the left. And if you notice, the next one is minus. So it's the same thing, except that it's moving to the right. So if let's say that it's a -3 or a +3, that's however many units we're going to be moving to the left and to the right. It's always the opposite behavior inside the parentheses. Inside the parentheses, opposite behavior. Let's move on to number 8. Describe the effects of K. K is on the outside. So we're going to notice how we're going to have plus or minus K. All this really does, plus K, it moves the function up and it moves the function down. So when it says plus, moves it upward, the K moves it downward. So here we have it shifts K units up or K units down. The best thing to do with these problems is just graph it. Graph the problem and just see where it moved. Most of the problems will start at the origin, right in the middle of the graph. And as you move it to the left or to the right or up and down, you're going to start seeing how it changes. And we're going to do an example here at number 14 to show you how it moves left and right. Okay. The next one is the effects of A. Now, when A is greater than 1, we have a vertical stretch. Which means the function is going to get narrow. It's going to come together when let me see. When A is bigger than 1, we have ourselves a vertical stretch. Okay, it's usually going to get a lot narrower to each other. When A is less than 1, like let's say we have another number 11, when it's a fraction that's like less than 1. So if A is between 0 and 1, let's see. So if you're dealing with a fraction like 1/3, 1/5, 7/8, anything less than 1. Now you can have a fraction that's bigger than 1, like 5/2, which is the same thing as 2.5. 2.5 would be considered bigger than 1, so it would be a stretch. So you just want to make sure that the fraction is less than 1. Not necessarily a fraction, just a fraction, but as long as the fraction is less than 1, between 0 and 1, we're going to have ourselves a vertical compression. Which is just another word for saying it gets wider. So if you're dealing with a parabola, it's going to get wider. And if it's a stretch, it's going to get skinnier, narrower. Okay, that's the kind of thing that you're going to be able to see from the graph. What I recommend, and as I said earlier, just graph it. What does it look like? Does it look narrow or does it look really, really wide? And that's what you say is what's happening in the numbers, in the situation. What happens to the effects of A and the function? Well, here, whenever we're dealing with a number in front of the function in front and it's a negative number, it could be -1, it could be -10, -30. If it's a negative number, it's going to reflect the function over the x-axis, or it'll flip it over. There's several ways of saying that. I'm going to say reflects over the x-axis. So anytime that you have a negative number in the front, it's going to flip it over. If it's not negative and it's positive, then you know that it's pointing up. Right? It's just going to point up. If the A is positive, it's pointing up. If A is negative, it's pointing down. Now, we didn't really talk about number 13, but whenever you have a negative inside the parentheses, like negative x, not like here where we have x minus a number, not this kind of negative, like negative in front of the x. This is more of a topic for next year. This is going to deal with a reflecting over the y-axis. You're rarely going to see these examples until you get to pre-cal. But I wanted to include it here just because I think I brushed it and I talked about it with some of my classes, but not all of my classes. But if you do see that scenario where it's a negative x inside the parentheses, maybe it's like, maybe the problem says, I'll change the colors for a second. Maybe it's like negative x plus 3 or negative x minus 3. This part in front, that negative, is going to flip it over the y-axis. We're not going to talk about that very much, at least not this year. You'll talk about it in pre-cal if you take pre-cal. Okay, let's move on to number 14. 14 is our actual first scenario. Here we want to talk about the effects of this function. Here we're going to combine all of these rules into one problem. We have a negative in the front, we have a negative inside, and a 3 on the outside. Now, the negative in the front is going to flip it over the x-axis. It's this rule. So it's going to be reflected over the x-axis. The minus 1 inside the parentheses is this right here. So we're always going to move it 1 unit to the right. And the plus 3 is this rule. It's going to move it 3 units up. So this function is going to be flipped over the x-axis. It's going to move 1 to the right and 3 units up. And that's what we want to say as a description for this problem. So reflect it over the x-axis. Or upside down or pointing downward or whatever you want to say. The first thing that's happening here, reflect it over the x-axis. The next thing here is moves 1 unit to the right. Remember, inside the parentheses, it's opposite behavior. So if inside the parentheses we have a minus 1, right, it means 1 unit to the right. I'm not able to separate that one for some reason. Here. And the plus 3 is going to move the function 1 unit up. Sorry, 3 units up. And I'm about to show you here on a graph what that looks like so you can compare those. Now, we're comparing it to the parent function. The parent function is x squared. So how is this function changing this one, right? And it's going to do this in here right here. Let me show you guys real quick. I'm going to pull it here to the side. Let's graph this on Desmos real quick. So I'm comparing it to this function. Okay, this is my parent function, the x squared. Now, when I start putting a negative in front, notice how the negative flips it over the x-axis. Now I'm going to add the minus 1 inside the parentheses. Minus 1. Notice how it now moves 1 unit to the right. This vertex got moved. It moved over 1. Before that, it was just reflected because it was negative. The minus 1 moves it to the right, and then the plus 3 moves it upward. So you see how this orange flipped over the problem? The vertex flipped over, it moved to the right, and then it moved up. That's the effect of this plus 3. If I had done plus 10, it would have moved up 10 units. But since it's only plus 3, it's 3 units. If I had done minus, it would have gone down 3 units, but the plus moves it upward. So really, if you have a problem like this, what I recommend is just graph it. Compare it. Where does it move? Where does it change? It starts at the origin, it flips over, it goes 1 to the right, and 3 units up. Voila. This is really the biggest thing about this unit. Let's talk about another example. Domain and range of this function. Okay, let's talk about the domain and range. So I'm going to graph this function. I have negative x plus 2 plus 2 minus 4. Okay. I want to describe the domain and range of this function right here. Now, the domain of a parabola is always going to be from negative infinity to positive infinity. It's always going to go, notice how the arrows here, if I zoom out, the arrows just keep going. The function just never ends. It's just going to keep going this way, both ways. The parabola goes side to side every single time, right? So the domain is from negative infinity to positive infinity. And you can put it in parentheses, or you can even say x is the set of all real numbers. You can say a million things about the domain. The range, domain is the same for all parabolas. The range is the one that's dependent on this vertex. Because this vertex is a maximum, that's going to be the highest point you're going to have. The highest y value is negative 4, which means the graph starts here at negative infinity and it goes all the way to negative 4. That's where it stops. You can also say, why is everything less than or equal to negative 4? Because it starts at negative 4 and then it's everything below it. Okay? If this function was pointing up, the domain stays the same. It's still negative infinity to positive infinity, but now it goes from negative 4 to positive infinity, or everything greater than negative 4 because it's pointing upward now. So the range is really dependent on where it starts or where it ends. Always start with the lowest value and ends at the highest value. In this case, it starts at negative 4 and it goes to positive infinity. Our original problem is upside down, so it's the other thing around. It starts at negative infinity and it goes all the way to negative 4, or from negative 4 all the way down to the negative numbers. There is an entire video on just domain and range in case you do have questions more over domain and range and how to do that. Okay, let's see. Let's talk about another example here. Number 16, a function that is represented by f of x, just any really function. F of x represents any function, has this happening to it. There's a negative in front and there's a minus 2. What does the negative do to the function? This negative, remember, if it's in the front, the negative flips it over the x-axis. So we're going to say it's first reflected over the x-axis. That is the first thing that it's doing. It's reflecting over the x-axis. What does this minus 2 do to it? Remember, the minus 2 is on the outside. So minus 2 just means it's going to move the function down 2 units. I'll just erase this other stuff. It got caught together. So let's recap. The negative in the front flips it over, and the minus 2 on the outside, it moves the function down 2 units. And we just say f of x because it can be any function, right? It can be any function that's being moved or reflected or that kind of thing. That's the bell right there. So the last one that we want to talk about is a function f of x. Let's talk about these transformations. This is another scenario. Remember, now the x, the stuff is inside the parentheses and on the outside. What are the effects of those two numbers? Well, the x plus 5 is inside the parentheses. So whatever the function looks like, it's going to move 5 units to the left. Remember, inside the parentheses is opposite. So 5 units to the left. That's the first thing that we're going to say. Shifts 5 units to the left. To the left, to the left. Sorry. Move the unit 5 units to the left. What does the plus 4 do at the very end? Well, the plus 4, since it's at the back, it moves the function up 4 units. And those are the effects of those two things. The plus 5 inside the parentheses moves it left and right. And the number on the outside moves it up and down. Since it's positive 4, it moves it up. The plus 5 is opposite because it's on the inside, moves it to the left. Those are really all of the rules. Now, in general, we do want to make sure we know what any function will look like. These are the 10 different functions that we've spoken about. We spoke about the constant, the quadratic, the line, square root. All of these functions, we spoke about what they look like. You should be able to identify the domain and range, the line of symmetry, where if it cuts it in half, if it even is possible, the x-intercepts and the y-intercepts. One way to do any of these problems is whatever problem you're given, graph it on Desmos. Put it in here on Desmos. Desmos will show you what to do. Graph it, and it'll tell you everything about it. Okay, it'll tell you what it looks like, and then from there you can decide if it has an nexus of symmetry, all of that stuff. Now, I also have information on all of these parent functions in our folder in our classroom. If you look at the second quarter, the first week, that's the very first thing we spoke about in the second quarter. Week number 9. You see how we have parent function intro notes and parent functions. Parent functions takes you to all of the parent functions on Desmos. So here you have all of the parent functions. You can see that what does the square root look like? Click on it here, and then you can see that the square root function looks like this. What does absolute value look like? Right? So you click on it, the absolute value looks like a V. So you can click on here and mess with this. You can also even go in the same folder, right? In the exact same folder, the first week of the second quarter. Again, you're going to be able to use all of this in the midterm. Parent functions introduction notes. Here, you'll have access to the notes that we spoke about in class of what they look like. It even tells you the domain and range, right? It tells you the graph. It tells you the function, the name, domain and range. So this is going to be a very useful source that you can use on the midterm as well. All parent functions, it tells you the domain and range and inequality notation. All right, guys, I hope this helps. I hope you find yourself with more clarity and able to solve these problems in our Unit 2 review. Remember tomorrow to tune in again for Unit 3 solutions, and I can explain the next portion to help you review for the exam. As always, you have access to more YouTube videos than just this one, where you can go back and read the titles and watch the videos that you need help with the most. You guys have a great day, and as always, calculator.